Okay, in the last video, we derived the relation for relative increase in conductivity and also for the relative conductivity. Relative increase in conductivity. Uh, Relative increase in conductivity, which is given by this relation. Now, the only unknown quantity in this equation is delta n. Delta n is unknown. So, in order to calculate this unknown quantity, we will do some further calculations, and for that we will consider the phenomena of light which is falling on this semiconductor slip. Suppose, let me check. Okay, suppose that the incidence of light on a semiconductor slip or semiconductor material causes the creation of free carriers, like it create electron and hole. So the situation become one of the non-equilibrium situation. If we have extra electron and extra holes, then the situation is non-equilibrium. Now there are two factors which lead to the variation of n, like the variation of number of electron because of incident light is due to two factors, and the two factors are like the free carriers are continuously created. Suppose we have electrons here in the valence band and conduction band is, let's suppose, is completely empty. If light is continuously falling, then each photon is absorbed by each electron, or each electron absorb a single photon and jump to the conduction band. So we have electrons here and holes here. Another electron absorbs the other photon and jumps to the conduction band. So we have a hole here and one electron here. Another photon will be absorbed by this electron, so it jumps to the conduction band. So there is a hole. So free carriers are continuously, number one, free carriers are continuously increases are created by the incidence of light beam. Incident of light beam. Now, what will happen after some time? Now, these electrons will not stay there for a longer time. So, after some times, they will de-excite, and during this de-excitation, they will fall to the same place and occupy the hole here. So, excess carrier are also continuously annihilated. Like this electron come back and take the position of this hole. So we have the excess carriers now vanishes. So we can say that the second condition is excess carriers are also continuously annihilated by recombine with other, by recombination of electrons with holes. Like the lifetime of this electron in the conduction band is very small. So So what it means? It means that these electrons will jump back to the valence band. Once it jump back to the valence band, then the electron gone from here, and also once it's jump back to the valence band, it occupy the place of the hole. So the hole also gone from the valence band. So it means that excess carriers are continuously annihilated by the recombination of electrons with hole. Now the recombination of carrier is present whenever the concentration of carrier different from that of equilibrium. In equilibrium, if we have, let's suppose, four electrons here, four holes are there. These, let's suppose this is the equilibrium condition. Now if the number of electrons in the conduction band, let's suppose, becomes 7, then here the holes also become 7. So these excess charge carrier are now 4. So 4 extra electrons are created here and 4 extra holes are created here. So the recombination, now once the number of electrons or the number of carriers, carrier concentration or the carrier concentration, like the number of electron and the number of hole concentration, differ from the equilibrium, then there is a carrier recombination of carriers. So we can say that the rate of change of carrier concentration is the rate of change of carrier concentration is equal to, we have G minus N naught over tau. Now what this equation means, I will explain it here. Now G is the rate of generation. This is the rate of generation. The number of carriers created per unit time or per unit volume. This is rate of generation of electron per unit volume, like the number of electron generated per unit time in a unit volume. This is called rate of generation. Now this rate of generation is due to absorption of light, okay? And the second term on the right here, this term is basically describe the rate of recombination of electrons, like how many electrons recombine with hole in a unit time. So this basically show the rate of recombination of electron, and this tau is called the recombination time. Recombination time. And this recombination time is basically the lifetime of free carriers in the conduction band or in the valence band. Now this rate of charge carrier concentration, rate of change of carrier concentration is denoted by dN over dt, which is equal to G, the rate of generation of electron per unit volume, plus minus rate of recombination. So this rate of carrier concentration dN over dt, rate of change of carrier concentration, is the rate of generation minus rate of combination, and tau is the lifetime of carriers concentration. Now in a steady states, like if the rate of generation, is equal to rate of combination. We call it steady state. In that case, rate of change of carrier concentration dN over dt will be equal to 0, because if we have one pair of electron and hole generated, then this is the generation, but there is one pair of electron and hole are now combined. So if we create one pair, then there will be an annihilation of one pair. So in that case, rate of generation is equal to the rate of combination. So there is no rate, the change in or the increase in carrier concentration will be equal to 0. So in that case, G is equal to N minus N naught over tau. Now N minus N naught is basically delta N, the increase in number of electron over tau. From that we can calculate the value of delta N, which is G times tau. So if we know the rate of generation and the lifetime of carriers, then we can easily calculate the number of electrons or number of holes due to falling of incident lights. So this quantity is also known now. So if we put this equation here in this relation, then all the quantities will be known. So delta sigma over sigma naught. So delta sigma over sigma naught will be equals to, we have E delta N mu N, E delta N mu N, and we have B plus 1 over sigma naught. So this will become E, instead of delta N we have now G tau, and mu N, and we have B plus 1 over sigma naught. So all the quantities are known now, so we can calculate the relative increase in conductivity easily, because all the quantities are known in this equation. So this is all about photoconductivity. In the next video we will move towards the Raman effect in crystal. Thank you. Oh, sorry.